Hello there. Let's do another inverse problem, this time involving square roots. So once again, consider this your y, and we're going to swap those x's and y's. Okay, I want to isolate and get y by itself. Normally I'm used to y being over on the left-hand side. Right now it's on the right. It's also negative. So we could move it over to the left-hand side by making it positive. So that's going to become now positive square root y plus 1, and that x, we'll move that to the other side by subtracting it, and we'll have 2 minus x. So I effectively subtracted that x and added that root y plus 1, and they swapped sides. Then what we can do is we can square the entire side there to get that y out of the square root symbol. So remember how to distribute over on the right. It's not simply 4 minus x squared. And lastly, then we can subtract the 1. Let's put this in order. So it's x, whoops, funny looking x's, x squared minus 4x plus 3. Now, you got to be a little bit careful because this by itself actually isn't the inverse. And to see what the inverse is, it's helpful to get an image of the original. Okay, so it can be difficult and a little bit confusing of what these shapes look like. I recommend plotting points. So if I stick in a 0 for x, we're going to wind up with 0 plus 1, that's 1. The square root of 1 is 1. It's not negative 1. The square root is just taking the positive value of that. That's why we have to write plus minus out in front. Here we just have a minus. So we have 2 minus 1, so that's going to give us the point 0, comma 1. Now, as far back as we can go, the x could be negative 1, but x can't be anything less than negative 1. So at negative 1, it's going to kind of bottom out. So if I stick a negative 1 there, I'm going to get 0, and then I'm going to have this point over here at negative 1, comma 2. This was 0, comma 1. So we get this kind of sideways opening thing. If x is 3, then we're going to be over here at 0. Because we can stick in a 3 here, we get 4, square root of 4 is 2, 2 minus 2 is 0. And you can see that this is going to be a sideways opening part of a parabola, not a full parabola. Now if we graph this one, oh, that's kind of challenging. Let's see here. What's a good way to graph that? We could complete the square. So x squared minus 4x plus 4 plus 3 minus 4. So x minus 2 quantity squared minus 1. Okay, so that seems to be a pretty good way to graph it. Vertex form's always nice. So it has a vertex at 2, negative 1. 2, negative 1. Notice this makes sense, and it's going to be going up, boop, boop, and like that. Now, altogether, it's a full parabola, but the original shape there was only like half of a sideways opening parabola. So we got to figure out, well, which half is it? Is it this half or is it this half? So remember that we're being reflected over this line. So that does reflect there. Those coordinates are swapping. That's good. We want that. This one here is going to swap over to this point, so we must be using this side of it. So there's a domain restriction on this rule. So this whole thing here, inverse of x is, so we had the parabola, x squared minus 4x plus 3, but x has to be less than or equal to 2. And that way we're going to get this part of the sideways opening parabola, not that one. Actually, it should hit there. Boom. It should be hitting the points 0, 3. If I stick in 0, I get a 3 out of there, and it should be agreeing at that intersection point, wherever that happens to be. Is it 1, 1? No, it can't be 1, 1. That's 0, 1. Now there's another way to look at this one too, of what that restriction is, and that has to do with domain and ranges. Alright, in the original one, this blue one over here, the domain, that's the interval of all x's that we can be, and we see that the domain on that one is everything greater than or equal to -1. So x is greater than or equal to -1. The range, that's here we're going down, that's y less than or equal to 2. We can be the point -1, 2, so -1 and 2 are included in those intervals. Now on the red one here, if we're looking at the graph, as far as x's go, we got to be over here on the left. So that's going to be, what do we got here? X is less than or equal to 2, and the range, you can see there's our minimum, we got to be greater than that, so that's y is greater than or equal to -1. And once again, you can see that the domain and range there, and those inverse equations are flip-flopping. We lost this part of the quadratic. We can't have that. It wouldn't pass the horizontal line test. It's just this part going down and this part going up. And then you can flop that over that axis there, and all the parts will match up. Thanks for watching. Character and Scholarship for Life.